Okay, this is going to be a video demonstration of the completed DIY 3220 point breadboard project. As you can see, I have gone ahead and put some labels on here just to explain what everything is. I guess what I can do is I'll start from the side of the box here. You see that we've got our input port for a 12 volt DC charge adapter, and I have a label here showing that. Again, this green LED right here is our indicator light to show when the power jack is on. We have our two output binding posts here. The yellow one represents the 6 volt output and the blue one represents the 9 volt output. And then we have our common ground. We have this red binding post here is for our benchtop power supply input, and this jumper wire here is our benchtop power supply output. So when you're using a benchtop power supply as your power supply for your breadboard, you would just take your jumper wire pin here to input that voltage into your power rail here. So you can see here I have a label. All I did was just create it on a free graphics website, and I just printed it off, and this says benchtop power supply input only, no output, because this is our input from the benchtop power supply and this is our output. Here we have two other smaller binding posts, a red and a black one. These are our output binding posts for the onboard 9 volt battery supply. Again, if I open the inside, remember we installed a 9 volt battery box inside here, and we have an onboard power supply from the 9 volt battery, and you can see that there's a label here showing that, and this switch is to turn that 9 volt battery supply on. You can see here near the bottom of the box two different labels. Remember, we installed two separate toggle switches here. This side is for turning on your power, whether it be the power from the power jack or the benchtop power supply. And then we have our choice between 6 volts and 9 volts output on this side, which controls the output voltages from these two binding posts. So what I'll do is I'm going to plug the 12 volt charge adapter in. I've already got it plugged into the wall outlet. That's ready to go, and I'm going to, just for demonstration purposes, I'm also going to input power from my benchtop power supply, and I'll put my negative into the common ground binding post. I'm going to turn that power supply on. So at the box here itself, nothing is on. To turn the power on from the power jack, I got to turn towards this direction, as you can see on the label here. This is switch number 1. We see that the green LED comes on, and this indicates that the power from the 12 volt charge adapter is being fed in, and it's ready to control these two outputs. And we control which one we want to use by switch number 2, or this switch over here. So if I switch it to the left, the yellow indicator light comes on, which means that we are now feeding power from the 12 volt charge adapter, and we're stepping that voltage down to 6 volts output from this binding post. And if I turn my multimeter on and I touch the common ground and the yellow binding post, we see that there is 6 volts output. Now I can turn that yellow indicator light off in the off position on switch number 2, and I can turn it to the right, indicating that I'm turning on the 9 volts. We see that the blue indicator light is on. That indicates that we are now outputting 9 volts from this binding post that's being fed in again from the 12 volt charge adapter, and it's stepped down to 9 volts. So if I use my multimeter, touch the common ground, and then touch the blue binding post, we see that we have 9 volts output on the multimeter. I will turn that off. So now I can choose to switch the supply coming in from the wall outlet or the 12 volt charge adapter, noting that the green light is now off. And I can turn this switch number 1 towards the right, meaning that I'm now using the bench top power supply coming in from these 2 lines. The red light is on, so the bench top, you can see this label here, bench top power on red, and we see the red LED on. So that means if I were to touch the common ground here and then touch the output jumper wire here, we should read, I have, before I touch it, I'm going to, for your information, that I have my benchtop power supply set to 12 volts, so we should read 12 volts on the multimeter. And we see that we are reading 12 volts on the multimeter, so we are outputting 12 volts from the benchtop power supply. And if I were to want to use that 12 volts from the benchtop power supply, I take the output pin and place it into the positive of my power rail, and I can use jumper wires to connect wherever I need to on my 3220 point breadboard. I can choose to turn the benchtop power supply off. Now both of my switches are in the off position, switch 1 and 2. I can choose to use the onboard 9 volt battery supply by flipping this rocker switch here. If I turn it on, a white LED indicator light comes on. Our label is in white here, showing our positive and negative for these 2 binding posts from that 9 volts. And we also have on the label notifying us that battery power on white. So if I take my probes from the multimeter and I touch both negative and positive here, I read a little over 8 volts. It's just because I have not charged the 9 volt battery on here. I am using a rechargeable 9 volt battery. If it were totally charged, we would be reading a voltage of around 9 volts, but currently it's just over 8 volts, but it is working. So again, just to kind of go overview everything once again, we have our completed 3220 point breadboard. We set up our breadboards on our art box here. We use the art box to hold all the electronics within all the electronics for the power supply, all the work that we did in the build videos. It's a 2-part video 1 and 2. We have the ability to use a power jack 12 volt charge adapter again. We have the ability to use benchtop power supply, and we have ability to use a 9 volt battery. And again, I just created these labels here just to show what everything is and what everything is for. And I also printed out myself a little resistor chart here, so I have that next to me at all times, so I'm not constantly having to look somewhere else for resistor sizes. I have my own resistor color code chart right here that makes things very convenient. So I hope that you took the time to create this project yourself. I thought it was a really fun and neat project to do. I hope you enjoyed it. Thank you for watching, and until next time, keep at it and stay motivated.